Okay, so for this one, we're just going to do part B, which in my opinion is the easier way. By easier, I also mean just more efficient way to solve for these complex powers. When it says complex form of apparent power, what it means is the complex power S. And that's because the S with a bar on top, that's a vector, and that's like saying S angle theta S. This right here is complex power. The S with the bars is apparent power. And this theta right here is what we're going to use for the power factor if we need it. Cosine theta. I'm calling cosine theta S. I think some people also call it theta VI because that's what it will be, is theta V minus theta I whenever we use this equation. That should have a complex number right there. Okay, so the first step that I'm going to do whenever I do these is I'm going to find Z total. If I was given some of these boxes like we have sometimes where it says watts and VAR, or maybe it's a box that says VA and a power factor, well then I'm going to solve for Q in each of these boxes by solving for some little power triangle at each of these, where S is the hypotenuse and P and Q are the legs of the triangle. And then I'll just add up all my Q's and add up all my P's, right? P total plus J Q total, add up all the P's, add up all the Q's, and that gives me a vector P plus JQ in the rectangular form. And if I needed to put that into the polar form, I can just go from rectangular to polar and it would give it to me in the polar form. But that's not what we have here. What we have here is elements. So the first step that I do is I put these J components on it so I don't forget them. That one's a real resistor. So my Z total in this case, I have 15J is in series with 30. Those are in parallel with negative J20. And all of that is in series with 10J. Does anyone need me to go over how to put that into the calculator? Because I can if you would like me to. Nope. Okay. So then whenever I plug all of those into the calculator, my Z total in this one comes out to, I'll put it in the rectangular form because I like putting my Z totals. I like putting my Z in rectangular because it tells me what my elements are. Plus minus J 7.84. All of that's in ohms. So the total equivalent impedance of this entire circuit is 12.98 R and 7.84, which is capacitive, of X. So that's in the total circuit. Now I'm going to use Ohm's law, our favorite law, V equals IZ, to solve for I. I is V over Z. V is 120 angle 0. Z is 12.98 minus 7.84. J, don't forget the J. My I comes out to 7.92 angle 31.14 amps. The last step, S complex power is VI complex conjugate. V is 120 angle 0. I is 7.92 angle, and here's the only trick, is it's a negative because of the complex conjugate, 31.14. Remember that means reflected upon the real axis. In S, in this case, comes out to 950.4 angle negative 31.14. So if I was asked for S total or S apparent power, it's just 950.4 volt amps. Right? If I was asked for P power, now I need to go from polar to rectangular, and I don't even have to calculate anything. I can just do the conversion in the calculator. Polar to rectangular is no different than going 2.54 centimeters to 1 inch. It's just a notation describing it. Either way, the length would be the same. It's just a different way of describing it. Polar and rectangular are just different ways to describe the vector. So I can just convert that 813.45 minus J 491.48. That is still my S vector. But now, without doing any calculation, I can solve for each of the parts. Actually, I'll box that in red. And my Q is 491.48 VAR, volts, amps reactive, and it's capacitive because I have a negative J. So one more thing is if I had to draw the power triangle for this, so I've described it as VAR capacitive, but I would also need to draw the power triangle going down like this, right? Because it's capacitive, so this should be 491.48. This angle is going down from where it's flat, right? Here's 813.45 watts. S 950.4 VA. VAR Q, and this angle is 31.14 degrees. So that would be another way of saying this is capacitive because the triangle is going down like that.